microcontroller from a different manufacturer, and choose the device, which is choose the manufacturer Atmel and click on this plus mark. It will show the list of devices from this manufacturer. From this, choose a specific device, which is 8089C51. Once you choose the device, it will show the internal features, the number of IO lines, timers, counters, and with on-chip memory quantities, and click on OK. Now this is the startup code warning. You can choose yes or no. Just click on no. And now you people created a project on a specific target device, which is Atmel and 8089C51. To write the program, you have to open editor window. To open editor window, go file tab and select the option new. And this is the text editor. Here we can write our programs. Before going to write the program, go file tab and choose the option save. And now save your project as this is your program name, and you have to save this program name with .c extension compulsory. And after giving your file name, click on save. And where it is saving, it will show this path, and here you can start writing program. And this is the header file name for all 51 families. And for simple robot design, you require 2 motors, clockwise and anti-clockwise direction control. To control 2 motors in 2 different directions, you have to connect both positive pole and negative pole, controlled by controller. So I am declaring motor 1P, which is connected with one IO pin, and the other end which is also controlled by controller IO pin, which is connected with P1.1. And these are the 2 declarations required for one motor to control in 2 directions. And the second motor declarations, motor P positive end, which is connected with other IO pin, these are all motor declarations you are doing. You connected with the motors. And for giving inputs, now So doing the switches connections with the port 2. I am taking 5 switches, one switch for forward direction control and the second switch for reverse direction control, and the third switch to control the robot in left direction, which is connected with P2.2. and switch 4, which is connected with P2.3, and switch 5, which is used for stop the robot. This switch for forward direction, move the robot in forward direction, and the second switch, which is used for reverse direction, and third switch, which is used for left, and fourth switch, which is used to control the robot in right direction, and switch 5, which is used to stop. And from here main program starts. And initially assign the logics for all your motor pins as logic zeros. So I am not expecting any rotation from the motors. So initial condition should be all logic zeros. Then I will enter into the infinite loop to check the status of switches, which key you are going to operate. If switch 1, which is connected with ground one end, so I am testing the logic with 0. If switch 1 equals to 0, then what is the response I am expecting from motors? The positive pole as 1 and negative pole as 0 of first motor, and the second motor logics. So this second motor positive pole also 1 and second motor negative pole also as 0. Because of this positive pole logic ones for two motors starts rotation forward direction, that means clockwise, then automatically robot moves forward direction. Next, the second switch, which is connected with ground, and for second switch just I am making positive poles as zeros and negative poles as 1. So because of these logics, robo moves reverse direction. Next, for switch 3, motor, the first motor rotates anti-clockwise and second motor which will rotates forward direction. So robot turns to left because one motor is rotating clockwise and other motor is rotating anti-clockwise. So obviously the robot turns left side. In the fourth switch condition, so for this fourth condition just quite opposite to switch 3. So positive pole as 1 and negative pole as 0, and second motor positive pole as 0 and negative pole as 1. Now robot turns right so because of opposite poles making ones, the robot turns right. And the last switch condition, which is switch 5, for this condition all logics of motor pins which are zeros because you have to stop the motor so writing your program. If you want to see the errors and warnings of this program, just add this file to source group for compilation. To compile the program, select your project workspace window and click on this plus mark. You will get source group 1 and select source group 1 and right click, and you have to get the option add files to source group 1. And what is our file name? Just select your .c file and click on add and close. Once the file is added, it will get the plus mark for source group 1 and go project tab and build target. Now it will show the errors and warnings present with the program, and to see the output of this program with hardware simulation, select target 1 from project workspace window and create hex file. For that, just select the options for target 1 and give the crystal frequency as 11.0592 and highlight the option use on chip ROM. and select output tab in the same window and highlight create hex file option. Click on OK. After giving all these options, go project tab and build target. And this is your hex file name of your project. Just minimize your Keil IDE and double click on Proteus simulation tool. Now pick the devices from the library just by click on P symbol. So it will ask for which file, which components you are expecting. Just click on your device name, which is 8089C51. And if you double click on the component, it will come into the list. And you can take a driver IC, which is L293D, to drive the motors, and you have to take two DC motors, and for controlling your motors, just required switches. Just type button to get the component as switch. Now close this pick devices window and connect all components in the design. So just go through your connections, where you connected motor lines and where you connected your switches. So now all motor connections with port 1 and switches connection with port 2. Now choose this driver IC and two motors and 5 buttons which are required for operating your motors. And do all your hardware connections first with all your switches. So one end will be connected with IO pin and other end you have to connect with ground, and take the ground connection from terminals mode and select your ground and make it common ground connection for all switches. And now do the motor connections. All these out pins which are connected with motor lines, and input lines which are connected with IOs. So this driver IC, it can drive the voltage from 5 volts to 18 volts with 2 amps current rating maximum. and these input lines you have to connect with more IO pins, and output lines you have to connect with motors. And these enable lines and these 16 and 8 pins which are commonly connected with the power, and these 5 pins and 12th pin which are connected to ground. So after doing all your hardware connections, you have to browse the hex file from Keil Microvision. Just to get the hex file into this device, just double click. It will ask for program file path, and click on this folder symbol. You can choose the hex file path as robot.hex and click on open, and give the same clock frequency as 11.0592. Click on OK. And to see the response from motors by controlling switches, you can play your design. See the initial status of motors which are off state, and once you press the first one, the two motors starts rotation clockwise, so obviously robot moves forward. And to release this switch and operate the second one, now the motors are rotating anti-clockwise. And release the second switch and press the third switch. One motor is rotating clockwise and other motor is rotating anti-clockwise, so which will turn left side. And release the third switch and operate the fourth switch. Then this motor is rotating forward and this motor is rotating anti-clockwise. And once you operate the fifth switch, the two motors comes to off state. So this is the way you can design simple moving robots by controlling 5 individual switches for 5 different directions. Again you can see the switches operations. The first switch, 2 motors forward, and second switch, 2 motors reverse, and third switch, 1 motor clock, other motor anti-clock, so left direction, and fourth switch just opposite to the third switch conditions, and fifth switch for stop. This is the way you can design good applications by using Keil and Proteus combination for different applications. Thanks for watching.